Welcome back. In this part 2 of the compression video tutorials, I'm going to cover the 4 main types of compression, which is downward compression, which we covered in the first video, upward compression, downward expansion, and upward expansion. The best way of showing you this is to use a plugin that can actually do all 4. And FabFilter's Pro MB, which is a multi-band compressor, can do all 4. So it's the best one to use. Let's just pick a single full band mode. And if I click on this, my parameter controls come up here. We're now in what's called downward compression mode. Let me drag the range knob here, which serves a number of purposes. Let me drag it down to complete negative. Most downward compressors don't even have a range knob. And if they do, it isn't for this function. It's actually to limit the range of compression. It's a wonderful little utility that I think all compressors really should have. But for this one, we're going to use it for something else. So let's leave it there. Right now, this is behaving in downward compressor mode. Ratio 4:1. I picked a knee setting. That's not hard, not soft. I've left look ahead alone for now. And gain compensation is something we'll talk about in a minute. Okay, mode, compress, downward. Let's play the audio. And I've brought the volume down so as not to blow our eardrums. I can have the analyzer show pre-compression, post, after compression, or as I prefer, pre and post. That way I can see what's happening to both. And to show you the difference between the two, between the pre and the post, extending. This brings it out even more. Let's get back to where we were and put the ratio back in the middle. We've now got the graphics side sorted out. We don't need this all pink, so I'll bring this range up just so as we can actually concentrate on things a bit better. Downward compressor. We covered this in the last video tutorial. Attack, release. If I extend the release further and further, you'll see this line almost stop moving. It's only moving on the highest transient peaks. But if I bring it down to here, it's releasing quicker and quicker. When you are using a compressor on the master bus, we tend to put the release in auto release mode because you'll get different areas of the music where some passages will be very dynamic and active with loads of transients and other areas won't. So we want to have that release vary throughout the program material. For now, I'll just pick the sensible value here. Attack. If I put it on 0, we have an instant attack. If I put it a little further up, it allows the attack transients to come through uncompressed. Again, I'll leave it on a sensible setting here so we can see this jump up and down. Beautiful. Let me also change the metering so we can see more of this information. Downward compression takes the audio above the threshold, compresses it down using the ratio. So, again, for argument's sake, let me pick a ratio 4:1, which means above the threshold, for every 4 dBs that's input, 1 dB is output, which means we're going to end up with a much quieter signal. Our dynamic range is also going to be compromised, so we need to boost. Most gain compensation functions on compressors can be flicked into auto mode, so they will automatically gain compensate. Lovely if you're doing work on the master bus. Maybe you don't need it when you're working on individual sounds. What happens when we take the range, and this is where the MB comes into its own. The minute I go into positive values, of course, everything got louder, and let me explain to you why in a minute. By selecting a positive value for the range, I am now triggering what we called upward compression. And you can actually see With a downward compressor, the signals above the threshold being attenuated, the signals below the threshold now are boosted. Why is range so important for us when we're dealing with upward compression? Because we're raising the noise floor along with all the audio, because everything below the threshold is being boosted up. We don't want too much noise. I know in a 24-bit system we're barely going to have any, but it will make things sound brittle. So it's a conscious decision you've got to make when to use downward compression or upward compression, and it varies from material to material, really. Okay, now that we've discussed downward compression above the threshold, upward compression, meaning everything is raised below the threshold, of course, all of these parameters still affect the behavior. So what's downward expansion? Well, if we use the range knob and go into negative values, what we're now doing is actually attenuating the levels below the threshold. In effect, we're making it quieter. So the minute the signal falls below the threshold, it gets attenuated even further, which means we're now again extending the dynamic range. So our perceived volume rises. Amazing what an effect it has. It really is. Not dramatic, but it's wonderful. What happens when we go into positive values for the range while in expansion mode? Well, we're now raising the volume of everything above the threshold and leaving everything below the threshold as it is. What are we doing again? We're extending the dynamic range. If you watch the dynamic range video, all that's explained. Okay, so we've now got upward expansion, downward expansion, downward compression, upward compression. All of them are quite subtle, but here's the deal for me. If I use the range using positive values and I throw in expansion mode, of course we're talking upward expansion. What's the equivalent of this? What's the equivalent of above a threshold raising our peak values whilst keeping everything else the same? Parallel compression. It's almost identical. I'm being anal and pedantic, but that's just because I'm a geek. Think of what you do when you're running drums in parallel, let's say. You have one channel, which is a compressed channel, which is fully wet, and you have the dry channel, which is the drums without any compression. And then you mix the two together. What are we in effect doing? Well, we're gain compensating and boosting above the threshold, while the rest is simply summing below the threshold. Upward expansion. There are other things we can do, but this is not meant to be a tutorial for the Pro MB. But we have all manner of filtering here that we can use for funky little tricks. I mean, we're in multi-band mode, right? So we could easily create another band and make that band, i.e. the low frequencies, flip them into mono, so we have mono compatibility for the low frequencies and they don't mess with our stereo signals. Really, I don't need low end or low energy displayed in stereo. And we can do all manner of other things. For example, we can use the external sidechain for the standard kick bass interchange pump vibe thingy. There's loads we can do. But really all I wanted to show you was what those four modes are. Downward compression. All the peaks above the threshold are made quieter. So everything above whatever the threshold value is made quieter by the ratio. The speed at which the compression takes place is determined by the attack knob. The release at which the compressor drops out is determined by the release knob, and this is gain compensation. You can either do it manually or we can have it in auto mode, the same as the release. In multi-band we don't tend to get autos all over the place because we want to have individual band control across a number of bands, so there's no real point having gain compensation on each band because we'll do that ourselves. This is meant to be a multi-band compressor. I'm only using it in single band, so you can see the 4 different modes in action.